Depending on where you live in the world, every time you turn on a tap, clean water flows out instantly. You drink it, cook with it, shower in it, and rarely think twice about where it came from. But that water didn't start out clean. In fact, the water reaching your home may have come from rivers, lakes, dams, or underground sources that contain dirt, bacteria, chemicals, and microscopic organisms. So how does that water become safe enough to drink? Let's break down how water gets cleaned, step by step. It all begins with the source. Most drinking water comes from either surface water like rivers, lakes, and reservoirs, or groundwater, which is water stored underground in natural rock layers called aquifers. Before this water can be used, it must be treated to remove physical debris, harmful microorganisms, and invisible contaminants. This process takes place at a water treatment plant. The first step is water intake. Large pipes draw raw water from the source and carry it into the treatment facility. At this stage, the water may contain leaves, sticks, insects, sand, mud, and even small fish. To remove the largest debris, the water passes through metal screens or grates. These screens act like giant sieves, blocking anything big enough to damage equipment or interfere with later treatment steps. Once large debris is removed, the water moves to the next stage, called coagulation. This is where chemistry comes into play. Tiny particles like dirt and clay are so small that they don't naturally settle out of the water. To fix this, treatment plants add special chemicals called coagulants, often aluminum sulfate or iron salts. These chemicals cause the tiny particles to stick together into larger clumps called flocks. Next comes flocculation. During this stage, the water is gently mixed to help the flocks grow bigger and heavier. As the water slowly moves through large tanks, the flocks collide with each other and combine. These larger clumps are much easier to remove than individual microscopic particles. After flocculation, the water enters sedimentation tanks. Here, gravity does most of the work. The heavy flocks sink to the bottom of the tank, forming a layer of sludge. Meanwhile, cleaner water remains on top. The step can remove a large percentage of dirt, bacteria, and other contaminants, simply by letting time and gravity do their job. The settled sludge is collected and removed for further treatment or disposal, while the clearer water continues to the next stage, filtration. Even though the water now looks much cleaner, it still contains tiny particles and microorganisms that can't be seen with the naked eye. During filtration, water passes through layers of materials such as sand, gravel, and sometimes activated carbon. These layers act like a physical barrier, trapping remaining particles as the water flows through. Activated carbon is especially useful because it can absorb chemicals, odors, and unpleasant tastes. By the time water leaves the filters, it is clear and free from most impurities. However, clear water doesn't always mean safe water. Harmful bacteria, viruses, and parasites can still be present, so the next step is disinfection. This step kills or inactivates microorganisms that could cause illness. The most common disinfectant used worldwide is chlorine, but some systems use chloramine, ozone, or ultraviolet light instead. Chlorine is added in carefully controlled amounts, strong enough to kill germs, but safe for humans at low levels. One major advantage of chlorine is that it continues working even after the water leaves the treatment plant, helping keep the water safe as it travels through pipes to homes and businesses. After disinfection, the water may go through additional treatments depending on local needs. Some areas adjust the water's pH to prevent pipe corrosion. Others add fluoride to help protect dental health. Minerals may also be added or adjusted to improve taste and prevent damage to infrastructure. Once treatment is complete, the clean water is stored in reservoirs or water towers. These storage systems help maintain steady water pressure and ensure there's enough supply during peak usage or emergencies. From there, it travels through an extensive network of underground pipes, sometimes covering hundreds or thousands of kilometers, before finally reaching your tap. The entire process is carefully monitored. Water treatment plants continuously test water quality using sensors and laboratory analysis. They check for bacteria, chemical levels, clarity, and safety standards. This constant monitoring ensures the water remains safe at every stage of the journey. It's also important to understand that water treatment doesn't end once water leaves your home. After you use water for washing, flushing toilets, or cooking, it becomes wastewater. This wastewater travels through a separate system to wastewater treatment plants, where it's cleaned again before being released back into the environment. This helps protect rivers, lakes, and ecosystems, and allows water to be reused as part of the natural water cycle. So in simple terms, water gets cleaned through a series of steps: intake, screening, coagulation, flocculation, sedimentation, filtration, disinfection, and final adjustment. Each step removes different types of contaminants, working together to turn raw, dirty water into safe drinking water. The next time you turn on a tap, you'll know that the water flowing out has gone through a carefully designed process involving chemistry, physics, engineering, and constant monitoring. Clean water isn't just a convenience. It's the result of one of the most important systems keeping modern society healthy and running every day.